Alright gang, welcome to Chapter 1 of System Analysis and Design. We're using the 11th edition of the text, and in this first chapter we're going to describe the impact of information technology, define system analysis design, and the role of a systems analyst. We're going to define an information system and describe its components. We're going to be able to explain how to use business profiles and different models. We're going to explain business internet strategies and relationships, including B2C and B2B. We've also got the ability to identify various types of information systems and explain who uses them. You should be able to distinguish among structured analysis, object-oriented analysis, and agile methods. Explain the waterfall model and how it has evolved, and discuss the role of the information technology department and the systems analysts who work there. So let's kick this into gear. Now, information helps companies. Now, we make better decisions when we have information to support those decisions. So if I gave you some statistics and said 9 out of 10 people do not like a product or service, and you're starting a business and you find out that 9 out of 10 people do not like what you're doing, that may not be the thing you want to do. Or you could focus in on the one person, the 10% of the population. 10% of the population can be a huge number depending on the population of customers that you've got. Now, information helps us make sound decisions. We can maintain customer loyalty. And it's something like, if you go into a store and they ask you what your zip code is, well, why do they care what your zip code is? They want to find out where their customer base is. And if they collect that data over time, they can crunch the numbers. That becomes information. Now they know where their store really should be because of where their customer base is. Now, information technology is a combination of hardware and software products and services used to manage, access, communicate, and share information. The changing nature of IT changes faster than just about any other industry. Now, one of the founders of IBM, his name was Moore, he's got this thing that we deal with in technology called Moore's Law. Now, Mr. Moore decided that, and it was his perception, that the capacity of computing would double every 18 months. That was the way things were going early on. So if the capacity doubles every 18 months, 3 years from now, it would have doubled twice. Now, if we compare that to something that we deal with on a day-to-day basis, we all know about fuel efficiency for cars. So let's say you want to go buy a car, and the current fuel efficiency is 20 miles per gallon. 18 months from now, if you go to buy that same car, the fuel efficiency standard would be 40 miles per gallon. 18 months later, 80 miles per gallon. 18 months later, the standard fuel efficiency would be 160 miles per gallon. And nothing else changes that fast other than IT. And IT does change that fast. Okay. So it can be tough and challenging to keep up with. But then again, there's so much going on, and it's always bright ahead of us because we've got so many things that we can do with the new technology. Now, system analysis design is a step-by-step process for developing high-quality information systems. Now, an information system is a combination of the technology, people, and data that perform some business function. Now, a business analyst is somebody that plans, develops, and maintains information systems. Now, they manage IT projects that include tasks, resources, schedules, and cost. And sometimes you may hear them referred to as a project manager, but those are separate, distinct tasks. or roles. A systems analyst may conduct meetings, deliver presentations, and write memos, reports, and documentation. Okay. Now, I said that a systems analyst sometimes may be referred to as a project manager. They are separate, distinct roles. The analyst is the individual that looks at the system and analyzes everything about it to come up with the appropriate solution or the system that we're going to create. So let's say a company needs something done. We'll have to their system, or they don't even have a system. System analysis will come in, design a system for them, implement it, and it's a cycle. It's a life cycle that we go through. And we'll talk about the different phases when we get into it here. A project management or a project manager, they manage a one-time effort and they manage the implementation of a project, not the development of the solution. So they're separate. Now, when it comes to an information systems components, we've got hardware, software, data, processes, and people. Now, the hardware, that's the physical components. Software, we all have pretty much dealt with Microsoft Office. We could deal with databases as well. There's many different systems, software systems that control hardware or work with hardware to help us maintain or create a solution. And here the author even talks about Moore's Law that we just spoke about earlier. Now, data is stored in tables. It's processed, or we have processes, I should say, which are tasks, things that happen. And people are stakeholders. They've got an interest or they're impacted by a system. I remember one time we had a discussion about a factory in a small town. And I said, who were the stakeholders in that factory? He said, everybody in the town. Even the guy that owned the gas station. He was a stakeholder in the success of that factory. Because if that factory closed down, people would move away and his business would diminish. And the fact that he was right across the street from the factory, he had a daily stream of customers going past his gas station. Now, business today is influenced by globalization, technology integration for seamless information access, and there's a rapid growth of cloud-based computing and services. Microsoft has Azure. We've got the ability to save stuff in Google. We've got Amazon Web Services. There's so many different things that we can deal with today that are cloud-based. Now, when it comes to an internet model, you hear the word e-commerce. Now, e-commerce is doing business over the internet. There's a user interface enables communication between a database management software and a web-based server. Now, we'll talk about user interfaces later. I've got a different perspective than the author does on this, but we've got two different sectors. B2C is the business to the customer, and B2B is business to business. So a lot of times we'll have businesses that just do businesses with other business, and they don't want to deal with individual customers. Now, business profile is an overview of the company's mission, function, organization, products, and the business process is how they do things. Now, is it important to know what a business's mission is? Or how people work together? Who works there? What do they do? Are these things important? when you're trying to understand the best solution for that organization? And answer is absolutely. Okay, so we've got to be able to model the business operations. So an order is received, check the customer status, verify the customer credit, enter the customer order data into the system, and then the order gets completed. That's a standard transaction. We have to be able to document and understand visually these systems. Okay? That's part of a system when we're doing our system analysis design. Okay? There's a current method where all systems are using a current backup. There's the current method, how they do things. And then we're developing how they're going to be doing things. And we have to understand what it's going to take to transition, and is it feasible to actually transition. Okay. We've got TP systems, or transaction processing systems, and all they do is just, it's like credit card processing. That's a TP system. We've got business support systems. They provide job-related information support to all levels of the company. It's like a help desk. There's knowledge management. And knowledge management is a large database that allows users to find information using keywords about that tie to specific pieces of information. Okay. Now, we've got different levels when it comes to the organization. We have to understand what users interact with, how systems are designed. And when I say systems, the organizations is really what I'm talking about. How does an organization tie together? How many levels of management, and how are people held accountable, or who do they have to answer to? Aside from that, organizations can have different departments, and all too often they become so segmented that one hand doesn't know what the other's doing. So if we understand here the different organizational structures from department to department or from level to level, we can develop a better solution or more effective solution. We've got top managers, they're looking at long range, 10 years or better. Middle managers are looking at a year to 5 years. And line level team leaders, they're looking at today, tomorrow, not looking a whole lot further out, maybe a week out at most. Operational employees, they're dealing with day-to-day basis, and that's it. Now we need to be able to model everything that we do in system analysis design. You've heard the term, a picture paints 1,000 words. It's true. We can create a business model, object model, data model, network model, or process model so that others can understand at a glance how do these systems work. Now, not only are we developing a solution, a system that we're designing, but we also have to be able to sell it. And when I say sell it, I mean that those stakeholders need to, I'm not talking about transferring money, I'm talking about them buying into it and saying, yes, this is what we want to have happen. There are times when somebody comes up with a solution and then they go to implement it and the users reject it or sabotage it so that it fails. So all the work that we go through to do, the better we understand these models and the better we can communicate what's about to happen to the actual users, the more successful our deployment will be. Now, prototyping is an early version of whatever it is we're going to develop. Let's say that somebody wants to manufacture a little toy. Well, they would create a prototype so that when they go to sell it to a company, sell the idea, here's what we're selling. Okay. It's not the full functioning version, but it's a prototype. This is what it would look like if we did go develop it or build it. Now, there's a lot that goes into developing a prototype, and they can be extremely valuable once we've developed them. Now, we've got case tools that we can use. That's computer-aided software. It helps us by providing an overall framework for the system development. There's a few different system tools or case tools that we can use, and they will actually generate program code in some instances that will speed up the implementation process. So we've got three different types of analysis. We've got structured analysis, object-oriented analysis, and agile or adaptive methods. And when it comes to structured analysis, it's time-tested and easy to understand. It uses the SDLC, or System Development Lifecycle. It's based on a predictive approach. It's process-centered technique. It addresses the data organization, the structure, relational database. That's something we've been doing for decades. It's broken down into 5 phases. Now, each phase is its own cycle. The whole thing is a cycle, but each phase is a cycle itself. And we'll start out with the preliminary investigation report. That's the systems planning. So systems planning will go through, and if it didn't turn out the way we wanted it to, we can start over and do it again. We get to the second phase, which is systems analysis. We've got a system requirements document, and if there's issues, we can go back and start over again. We go from system analysis to the system design, from system design to systems implementation, and from systems implementation to system security and support. Now, this is what we call the waterfall model. It goes from one to the next, to the next, to the next. These are, like I said, cyclical, and we may have to, say we get to system design and something's not the way it needs to be, we may go back one step, we may have to go back 2. So we've talked about the different steps. When it comes to object-oriented, now object-oriented, we deal with that in programming all too often. And in programming, we have what's called a class. Now, a class would be a person. So you see in this diagram, you see a person in green. So in programming, that would be a class called person. I can create an instance of that class called an instructor, and that instructor inherits the attributes and functionality of that parent class. There's the option to create different objects. So I create an instructor object. I could create a student object. The student object, it inherits the same attributes and functionality, name, address, and date of birth. Now, there may be other properties that we collect about that object, but the base from that class, all students would have that same base, and all students would have whatever we added to it. All instructors would have the base and whatever we added to instructors as well. Okay. Now, there's a system development methods when it comes to object-oriented development. So we start out with planning, analysis, and design. That's one phase. And from that planning, analysis, design, we will prototype out, test it, and then we may have to come back in again if need be. If it tests good, then we're good. Now, agile methods, they involve building and constantly adjusting a series of prototypes to user requirements. It's a spiral model. Now, we don't have a graphic of it. It's a series of iterations based on user feedback. So it's a lot of back and forth, back and forth, back and forth. Now, we've got other development methods. The two most common are joint application development, focuses on team-based fact-finding. And there's rapid application development. And that's, let's real quick see what we can do. And it compresses everything into a small process. And it's not as common as it had been in years past. So here's a common IT department. You've got a director of IT. Now here's a flat organization. We've got application development, system support and security, user support, database administration, network administration, web support, and quality assurance. Now, in the IT department, we've got each one of those departments that we just looked at and what they do. We've got that in the book, and there's no sense rehashing it over and over again. So a systems analyst investigates, analyzes, designs, and develops, installs, evaluates, and maintains a company's information systems. They constantly interact with users and managers within and outside the organization. The different roles associated with a systems analyst, I've talked about it before. There's so many things they've got to be able to do. They have to understand networking programming, how the organization works, have to have good people skills, good communicator. They need that technical knowledge, the people knowledge. They've got to be critical thinkers, be able to think outside the box. It helps to have IT certifications. It's not required. They do need a college degree in many cases because they have to understand the concepts. And where do we get these concepts of networking, programming, and management? We get those in college. Career opportunities, man, just about anywhere. We've got systems analysts all over. IT is one of the fastest evolving industries. We've talked about that in the past. And the different types of system analysis and design. In IT, we've got a combination of its hardware and software resources that make up information technology, used by companies to manage, access, communicate, and share information. We make better decisions when we are informed, have information. Types of information systems are enterprise computing systems, transaction processing systems, business support systems, knowledge management systems, or user productivity systems. We've got system analysis that uses modeling, prototyping, and computer-aided systems engineering or CASE tools. We've got the different approaches that include structured, object-oriented, agile, JAD, RAD, and from that, we get an initial idea of what system analysis and design is. Okay. Now, I'll see you in Chapter 2, and I appreciate you taking the time to